Welcome to 502 Conversations. I'm Brian Kirby, and my guests today are Dr. Kathleen Dyer and Dr. Raymond Hall, both of Fresno State. Thank you very much for being here.
It's good to be here.
And I wrote your bios down. I do have the information in my head, but I usually mess it up if I speak. So I'm going to read it if you don't mind. I know it appears like I don't know what I'm talking about, but maybe that's true. Okay, so Dr. Hall, I'll start with you. You have a PhD in physics. You worked 15 years at the Fermi National Lab in Chicago, is that correct?
Outside of Chicago.
Outside Chicago, and you were part of the team that discovered the top quark?
That's right. There was 2 experiments.
And you now teach at Fresno State in California, and you're interested in skepticism, philosophy of science, and physics, and among other things, correct? And Dr. Kathleen Dyer, you have a PhD in human development and family studies. You're a social science, and your research interest is in parenting practices pertaining to infant sleep. Parenting practices pertaining to infant sleep and how these strategies are related to attachment and emotional development. And you teach how to interpret research. And you combat nonsense such as the anti-vaccination movement, the Mozart effect, and you both study the pseudoscientific beliefs of college students.
That's correct.
Is that correct? Right. Independently, right?
Oh, no, we're a team.
No, we do that as a team primarily, yeah.
Oh, okay. All right, so because I just said a lot, let's talk a little bit more about exactly what you're... So I'd like to define some terms, if that's okay, because some of the things I read about in previous interviews, I wanted to ask some questions about that. So what is scientific thought, as you would define it? Because that would be part of what you're trying to get these students...
Yeah.
Or maybe you want to start with pseudoscience and what you're seeing, why you... Well, all right, let's back up. You're interested in studying pseudoscience in college students. Why? Or where did that come from?
Well, you know, part of the skeptic movement is we're concerned with the great harm to society that, you know, having beliefs in these things that are unwarranted can wreak havoc on. So I would say that when people believe in astrology, maybe it's hard to see where too much harm comes from that, but when people practice homeopathy, it's clear that they're not getting the medicine they need or they're throwing away money. There's just so many aspects of pseudoscience where there's a famous online resource called What's the Harm that kind of chronicles that, you know, if somebody believes that rhinoceros horn is an aphrodisiac, then that makes it very valuable on the market, and rhinoceroses get hunted to extinction. So just as a dramatic example, more in terms of health science, people don't get vaccinated for reasons that are just absolutely unwarranted. And that puts a lot of people at risk.
And did you see this? Most people, I would think, maybe this is what maybe you came into college, teaching college with some assumptions that the pseudoscience would be left behind in college students. Did you see a lot of it in college students, and so that's why you decided to develop it? Well, speak about this course that you teach. What's your favorite class to teach now?
Well, I love teaching a number of classes, but this critical thinking class is one because it gives me a general population of students. It's a GE course, so students from all majors and all echelons from freshman to senior can take the class. So it's a very diverse, interesting crowd. And in essence, we're just trying to give them the tools of critical thinking to assess whether something is worthy of belief. And I'm not sure that, I mean, we kind of thought that maybe college students would be less likely to believe in these things initially, just because there's kind of a threshold to get into college, and they have a little more knowledge and background knowledge. But we found that it's just not the case, that they believe in pseudoscience just as much as the general population. And I think if the goal of a general education is to give students the skills they need for life, we feel that these kind of critical thinking skills, and to be able to tell science from pseudoscience, or you know, just whether have something is worthy of believing in, we don't want them to leave college without having some of those tools.
Okay, and let me interrupt just for, we're having a conversation, so if you go on to something that I don't understand, I will stop and say, I don't understand what you're talking about, can you define it? Because I'm assuming I can't be the only one.
Sure.
So, Dr. Dyer, may I present this next question sort of to you? So, can you don't have to be super specific on this, and there's no test, but so you've mentioned critical thinking and pseudoscience. So can you just give me a definition of those so that...
I do this regularly in a class that I teach. I teach research methods in child and family science. So what we're trying to teach is the content of a lot of our classes has to do with, oh, the sequence of development and what predictors can lead to good outcomes in children or produce happy marriages and all this sort of thing, right? And so students are really interested in that. And what I want them to know, though, is how we came to know those things, because some of the things we know are you know, sort of more, the evidence is more firm for, and some of the things are a little, maybe mostly folk wisdom, right? And so I want them to be thinking whenever they learn about something, where did I get this information from? And that's research methods, right? So the prefix pseudo means false or a pretense of, right? And so what I want them to get is that you need to know, going into a field where you're working as a professional in child and family science, what we know from science and what is less well established. So pseudo would be the, so we know a lot of things that are from folk wisdom, or, you know, your parents told you it, or it makes sense to you, and that's one category of information that that we might do science on. But a really dangerous area of information is where something is actually pretending to be science, and that's the essence of the pseudo part.
Okay.
Is that it is a false or is a pretense of science. And so it will have some of the trappings of science. You'll have people presenting, oh, a study said da 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 da.
Can you give me an
right?
example, actually?
Well, I mean, a great example is the research, the early research, Wakefield's research on vaccines and autism, and then that kind of that blew up into conspiracy theory also. So anti-vax, but also the Mozart effect. You know, this is based on one particular study of college students who were given a paper folding task in a class, and it was scientific research, but the knowledge did not expand beyond it. It couldn't be replicated, and so on and so forth. But when people present it, when you know, folks try to sell things to parents so that they need to provide them for their infants, they say, oh, this is based on a study that found such and such, and your kid's not going to be good at math unless they listen to Mozart when they're babies, and so on and so forth. And they pretend that it's science. That's the pseudo part, is the pretense of science.
Okay.
Right. Another great example is homeopathy. So you've got this kind of history of homeopathy, Samuel Hahnemann, and he had these provings, and there's a fairly sophisticated kind of, if you read about homeopathy, there's kind of some sophisticated jargon, some sophisticated methodologies associated with it, and there's relationships in this kind of idea of how homeopathy might work. But it turns out that the experimental evidence to support it is weak at best and non-existent, or there's evidence actually that it is not correct, right? So the fact that people are still out there making homeopathic remedies and promoting it, they're no longer practicing science because they've abandoned the methodological aspects and interpretations that we've come to expect from science. And people are spending money on stuff that just doesn't work. So this is a problem.
And it's not even plausible, right? Based on what you know from
Well,
science.
based on our best current theories of
Okay,
chemistry and physics, for instance, which the methodology of science have shown us are correct. You know, science never wants to completely say something's impossible, right? But the claims made by homeopathy just do not hold up on any kind of rigorous study whatsoever. And they also contradict our best knowledge in those other fields of pharmacology, chemistry, and physics, to just name a few things that they butt heads against.
Are parents generally, so you deal mostly with parents, right? Okay. So they're a pretty easy target, right? Because especially the first child, they want to do everything correct. And there's no shortage of, well, when I was younger, I don't have children, but I remember there were no shortage in the supermarkets of parenting magazines with front, you know, big, this is what you should do, this is what you should do, this is what you should do.
Right.
And now the internet is out there with, this is what you do. So parents are an easy target, is that correct? I mean, they want to do the right thing.
I'd say an easy target for two reasons. One, it's probably the hardest job anybody ever does without any preparation, usually.
Oh yeah, how could you be prepared? Good point.
It's an easy target in that sense because people are desperate. The stakes are incredibly high. Most folks think that the job they do as a parent is, you know, the most important thing of their life, you know? People regularly tell me, I can mess up in my job, but, you know, if I mess up as a parent, that means I'm a bad person, you know? Like, there's a lot riding on it. But secondly, the other reason it's an easy target is that doing science, getting scientific knowledge, using scientific methods on parenting, on small children is really hard because the ethical constraints are profound, right? So if you want to know if there's a cause that has an effect, methodologically you really have to randomize people to groups, right? It's the essence of a true experiment is that, so let's say I have a really important question like, will spanking hurt my kid? If you really want the answer to that.
And by hurt, you mean?
Psychologically, physically, anyway, you know,
okay.
any kind of effect you want to have. Or if you think, will spanking help my child? If you ever want to answer a causal question, you have to do a true experiment, which means you have to randomize people to one group or the other. It's completely unethical to randomize a group of parents. You must spank, and you may not spank. And parenting lasts for a long time. So if you did try to randomize people, you'd say, for the next 18 years, right?
Yeah.
Until we get the effect. We cannot do studies like that. And most of parenting is that way, is that you simply can't do randomized controlled trials on parenting interventions. Therefore, the need is great, but the availability of very high quality evidence is really limited. So to try to get good answers to questions requires a lot of very, very sophisticated social research that's very, very hard to do. And so there's not as much evidence.
And when you mention that, I'm thinking, so what that would mean, if you want to study that, you would have to come up with some really well-designed questionnaire for adults and say, were you spanked? And how did you turn out? Or how, I mean, how do you do it?
Yeah, those have the problem of being retrospective. When people look back in their memories,
right?
And they're not very good reporters of experiences, you know, and so basically you want something prospective going forward in time, but that means you're going to be doing a study that's going to last 18, 20, 30, 40 years because you want it to be prospective. So that's a reason why we don't have a lot of data like that. We have some short-term data that you then try to extrapolate, you know, longer term, but well, you see the difficulties. You see the and then, of course, what people report versus what you observe them doing. When we ask people about spanking, we get one answer. When we observe punishing behaviors between parents and kids, we see a lot more punishing behaviors and criticizing than you see when people report. We know that self-reports are not terribly reliable.
Okay.
And so all of those things make the research very, very difficult.
I think what we're saying here is science is hard, but it's worth doing, right? It's really hard. Some of the things she's bringing up is that, well, what about some of these self-help books or the things you read in those articles? They're going to be mostly based on anecdote or personal stories and narratives, which are very compelling, but there's not the kind of careful, rigorous methodology here to really separate out what people thought happened from what really happened. And so it kind of delineates science and pseudoscience to a certain extent, is that others just don't hold they'll come to some conclusions, but how they got there may be based more on their ideology or what they thought happened or wished would happen than what really did happen.
And it's really easy for the pseudoscience. It's really easy to fake something that looks like science and for people to be vulnerable to it because they don't have a lot of other things going. You know, there's not a lot of other, they don't have access to science, to a lot of science.
Apart from Dr. Wakefield, who actually clearly faked the data, 11 kids, I can't remember, it was a very low number, it was really trumped up, and it wasn't even a study, right? So there must be some well-meaning pseudoscience studies that they're trying to figure something out, but they just don't know a good way to do it. Would you, so you would maybe say
well,
no?
And I'm not sure about Wakefield. I don't know, I don't have any inside scoop on him, but my guess is that he really believed what he was doing.
Oh, okay.
Research was really hard. He couldn't get it the way, and he couldn't get it. I think my guess is that he's well-meaning too, and I'm saying this not based on him, but anti-vaxxers, none of it's like fake on purpose.
Okay, there you go.
None of it's fake on purpose. Most of them are, boy, the people I talk to are mostly folks who have a niece or nephew, and sometimes a child who's autistic. it is awful to get the news that your child has a diagnosis that's going to affect you for the rest of your life and his life, and we don't know why it happened. Uncertainty is really hard for people to deal with. And so almost any answer is preferable to none. And so they're desperate to latch on to something. And, you know, so, oh, you're saying if I stop giving them no autism, but lots of problems with kids' behavior. If I don't give them red food dye or something, maybe this will end this practice. I don't know if it's true or not, but I'm desperate for something here. I'll try it because, you know, what else is there? And I think it comes mostly from that point, that feeling of powerlessness. You don't know what to do. You can see why people will latch on to anything.
In the world of physics, a famous thing that happened back in the 80s was this, it was in the news, with cold fusion. The claim that they had somehow reproduced the fusion that happens in the sun on a tabletop, and it was going to be the answer to all our energy concerns. And it turns out that there was some methodological errors that were made there. It's been written about many, many times, but I think that is pseudoscience, because people will still kind of, now, the thing there is that maybe there's this gray area. You can't just say everything's pseudoscience or everything's science. There could be things that are kind of somewhere in the middle. And there might be some legitimate questions where people want to pursue and see if cold fusion could happen. But because of this one incident where people were really, there was like gross negligence in the way they conducted their science.
And these were scientists.
They were scientists. They were using techniques, I mean, my frame on it, I have to review it, but is that they were electrochemists using techniques of detecting neutrons, which is really a little bit out of their field of expertise. Also conducting experiments that involved something called calorimetry, which is notoriously challenging. That's the measure of heat output of things. And it turns out measuring temperatures to very precise, to high precision, given environments or always interact with each other, is very hard to do. And they made some legitimate mistakes that would have been caught with peer review if they would have published this and let their peers review it before they went public with it.
Yeah.
And so there's missteps that were made. They didn't back down. There's a whole community now that thinks it's a conspiracy to squelch it, you know, based on the oil industry. But on the other hand, too, there were people that were actually pursuing this with legitimate, careful experiments that are now, if you mention the word cold fusion, you're not going to get funding, because this has kind of hurt that endeavor. So their mistake was so egregious that now the whole subfield of exploring that possibility has been tainted. And so I'm not sure that's exactly the right way to go about it, but they've clearly made mistakes, and there's kind of the pseudoscientific following now against them and conspiracy buildup about cold fusion, and there's still active groups talking about it.
Well, I think I read that they have a once-a-year convention in Italy or something, something like that.
That may be the case. I haven't looked at it for a few years, but yeah, we might even call that pathological science, where somebody stumbles across something and they just can't let it go. The famous case of Blond Lowe discovering what he caught were N-rays. It was all the rage at the turn of the century, 1902. People had discovered radioactivity, and so there were all these amazing properties and new physical things that we had discovered about the world that we didn't know before. And so an N-ray, why not? There's alpha rays, beta rays. Let's add a new one to the mix. But it turns out he was, again, ignoring some of the most important safeguards, blinding his experiment, using his senses as part of the measuring device and not understanding the limitations of those. And he went to his grave believing that he had discovered N-rays, and he was robbed of his, the important status that would have brought him with that discovery.
That brings me to an interesting question. When most people, such as myself, I guess I shouldn't say most people, I don't know, but I would assume most people such as myself, when they think physics, science, college students, that the critical thinking has already been taken care of. And I mentioned it briefly before, but I interviewed a physics teacher, an AP physics teacher at a high school, and I said, critical thinking, I said, do your students engage in that? And she just said, oh, we do it every day. Every day we do critical thinking based on the physics we're doing. And I said, well, I questioned that a little bit, because it doesn't seem to, like what you're demonstrating here, it doesn't seem that just because you're in the physics lab doing your experiments, then you still might walk out and go to your acupuncturist or your homeopath.
I know some of my scientific colleagues that do this kind of stuff. Not quite homeopath. Chemists and homeopathy don't get along at all, because it's just so ridiculous. But chiropractic is kind of common with some of my colleagues. And so I think that critical thinking is a pretty large domain of skill sets.
Can you give me a short definition right there? Critical thinking.
Well,
that's the problem, right? So
well, here we go.
people have struggled about this, right? So critical thinking has something to do with about being able to question your assumptions and your worldview, having some kind of methodology to inform your worldview in the way that's least likely to make mistakes. But I don't think there's a crisp definition of critical thinking. I would say that critical thinking exists as a set of skills that one acquires and uses. And the skill set that you might use to discern whether or not Bigfoot is out there or do actual biological research, they have some overlap, but they're not necessarily the same sets of skills. I think that a lot of scientific methodology skills have a critical thinking component, absolutely. But I'm not sure, for instance, one might say, like your physics teacher example, applying the math to a particular word problem might be a critical thinking skill. I think that's a very specific skill to solving physics problems using math. But, and clearly it's a higher level analysis or higher level in Bloom's taxonomy of thinking, but I'm not sure I'd call it critical thinking, right? But again, a universal definition doesn't exist, I think, that's at least a consensus.
Well, I think my point to her was that, you're assuming that just because they're in your physics class, they're thinking critically. And I'm talking about, never mind the homework, go out into the real world. How's it relate? Well, I guess what I should say is, if you go through basic math in school and you go to the supermarket and you get shortchanged and you don't know it, we'd think there'd be a problem there, right? You don't have basic math. You're not mathly thinking, right? But somehow you can go through high school, into college, do your AP physics, do your physics in college, and come out not thinking critically about certain pseudoscientific things. So that's where I was.
I like a definition of critical thinking that zeroes in on decision making and being able to evaluate evidence for decisions.
Oh, can I ask you a question then? Before you go into it?
Okay.
So let me give you this just popped into my head. Let me give you a mundane example. I'm not a parent, but I'm going to pretend to be one on TV. I'm a parent. I want to feed my child a nutritious diet. I go to the supermarket. I'm in the cereal aisle. There's 1,500 kinds of cereal. I want to give them a nutritious cereal. I look at all the labels. They're fortified. How do I put my skills to use? I don't know. I'm hoping that relates to what you were about to say, but what do? I'm confronted with all this information.
So, that's an interesting scenario. I personally like a definition of critical thinking that zeroes in on a decision-making component like that. Not all definitions of critical thinking do. So my guess is that the teacher you had interviewed before was simply using a different definition. I don't know what's the right one. But I would zero in on this one, and I would say if you're going to prepare, essentially, and you're talking about a consumer issue, right? If you want to prepare consumers to make decisions and use critical thinking to do it, then it seems to me you have to alert them to what are some of the strategies people are going to be trying to use to lead you astray, right? And so you'd be looking at the cereal aisle, noticing strategies that are being used that you now are savvy to the fact are not actually related to the health content of this food. So when they're using words like all natural, if you've been taught critical thinking, you should look at the all natural things and be a little skeptical and go, all natural. There's no actual definition for that.
Poisons are natural, things like that.
So I'm gonna move on. You know what I mean? And that's not an example that I ever teach anyone about, frankly, because it's not in my domain at all. I don't do nutrition, right? But I kind of zero in on the things that I think have a much bigger impact on, and not to say that health doesn't, but the things that are in my domain that have a huge impact on the well-being of kids. So look at harsh physical and psychological punishment of children. I care a lot about this. And if you come through my class, I want you to be able to make decisions based on evidence that people give in support of or against spanking. So I would hope in my field, for instance, critical thinking would look like if you're talking to your friend and you're having a discussion about spanking and your friend says, I was spanked and I came out just fine, I would hope a little red flag would go up for someone who's been in my class to recognize kind of a fallacy in an argument, right? And I like that definition. It's not the only definition.
And the fallacy in the
there.
argument is?
In that case, it's, well, one of them, there's several, but one is lack of an alternative hypothesis. I was spanked and I came out just fine. There's a lot of subjective validation about whether you're fine, but you might very well be, but we don't have any idea what you might have been like if you hadn't been spanked.
Not to mention you're biased.
That's right.
That's right. So there's plenty of them, right? But that's kind of, I know a person who, stories are a big part of counting hits and ignoring misses, and there's all kinds of fallacies that make that not good evidence. Testimonial evidence is never very good evidence for kind of objective truth of things.
It's one that parents use a lot, though, isn't it? Because they rely on how they were raised. My mom did this to me, or my dad, and look how I turned out, right? So I'm going to not investigate further. Why?
At some level, that's the fallacy of appeal to tradition, right? And so that actually comes up in almost every pseudoscience. Astrology, why should I trust it? Well, it's been around since the ancients. It wouldn't be around so long if it didn't work. These are the kind of logical things. So if it worked for my parents, it worked for me. Again, it's a little bit of an appeal to tradition where we know that, well, astrology's been abandoned by most scientists. It doesn't work. What is it supposed to do? It's supposed to predict personality based on the sun's location in the sky when you were born, or the planets, where the planets were in when you were born. And yet there are still people that take astrology very, very serious about it. If you do a Amazon.com search of astrology, you're going to find an awful lot of high-level, very detailed astrology books telling you how to write your natal chart just so carefully, what sector is Jupiter in, and how to then interpret all this to talk about the person's personality or what they should do for the future. It's very sophisticated in terms of how you get the information, how you assimilate the information, how you make your predictions, but does it work at any level? So there's like this, I would call it empty sophistication. There's tremendous sophistication. It obscures the fact that there's real no there. They're doing all this stuff. It looks like they're doing science.
There's real no there? What did you say?
Yeah, well, there's no there to actually research, right? So they're doing all this work and plotting all this and using math to some extent and understanding the locations of the planets and the stars at the time of birth. There's a lot of calculations to be done. And then there's a way to translate that into some predictions about the person's life or personality. But when you actually do a simple kind of blinded analysis, the famous one is from a guy named Sean Carlson. He did a study where he had astrologers. The idea is that they could predict something about a person's personality based on their date of birth. And so they basically also did a personality profile that was a fairly standard one used in the field. And they were given stacks of 3 personality profiles and 1 birth date, and they just had to match the birth date to the personality profile on that stack, and they had 10 such stacks. And so if they could actually do it, you'd expect them to get, but if they just got 1 out of 3, then they have no ability at all. And these kind of tests where they actually test the ability of the astrologer to actually make such a prediction and they always fail. They get exactly a random chance that they could have done just as good by throwing darts at the choices, and they would have come up with the same means. That's what we call a pseudoscience, where it looks sophisticated. From an outsider's point of view that hasn't investigated it, it has all these kind of trappings of science, but they make like these appeals to tradition, and when they actually put it to test, rigorous test, then it fails. Or they'll say, well, that's not the way we test things in our field. We do things differently. We do it much more subjectively, so they'll just eschew the methodologies of science.
And if I hear you correctly when you're saying trappings and sophistication, it's the system that looks impressive to people.
That's
if you
right.
Look from the outside in, they're doing all this work.
That's why we have this pseudoscience, right? And so it looks kind of superficially like science, but if you don't know what science really is, you could mistake it for it. And the practitioners themselves claim they're doing science. They say, look, see, we make calculations. We're doing science.
Well,
this kind of thing.
Do you mind if I stick on this for one quick minute? Because I remember reading in your bio or something about you that as an undergraduate teaching assistant, you tried to distill the difference between astronomy and astrology. Does that mean you were a believer at one point and you really looked into it? What does that mean?
It meant that when I was teaching astronomy, I'd get a lot of people kind of confusing the two words. And
simple confusion.
Yeah, so the students or people that would come participate in the at the evening telescope viewing sessions, they would ask me things, well, what about astrology and what's your sign? And then I'd say, well, that's kind of separate from, I know because there is some overlap, astronomy still uses kind of as a map of the sky, the constellations, and it's kind of ornate, and they'll superimpose, like Orion, the hunter over the stars there, and it's kind of just historic accident that we map out the sky. Where is that star? Well, it's in Orion's belt, for instance, right? But that's really the only overlap. For instance, astronomers don't usually like stories of how the constellations got their names. We're more curious about the stars themselves. Or somebody that's more prone to astrology, that's fascinating to them, how the constellations got theirs and the significance that might be put on the names and illustrations of the constellations, and they put great meaning on that. So it was kind of like I wanted to find out for myself, well, where is the boundary there between these two disciplines? And of course, they kind of pulled away from each other. They were kind of the same thing before Galileo and Kepler. And after that, after Newton's discoveries, then astronomy and astrology started to go separate ways. No longer were we using astrology to predict personal destiny and personalities.
So that brings me to another question, perhaps for Dr. Dyer here, because you're talking about personalities and such, but wasn't there another parenting, I wouldn't call it a scam, I guess, but wasn't there something just a few years ago about successful sports people are born at a certain time of year?
Oh, yeah, and that...
What was that? That's a parenting, and then people are trying to...
Well, and this, I would not say that's pseudoscience. It was a finding of scientific inquiry, but it's related to school entry.
Okay.
So in California, I know rules are different in different states. But in California, if you're born before December 5th, then you can get into the kindergarten class. But if you're born December 6th, then you have to wait till next year and start kindergarten next year.
So you're a little bit older and more mature.
So you'd be older, right? And so these things, not for any one kid, but in patterns of large groups of people, when you get a class of kids, those who are older in the class are going to be physically matured earlier, and if that matters, because there's a lot of physical growth going on during that time frame. So if you look at the adolescent growth spurt, a lot happens in a year between 12 and 13, or between 13 and 14. So if you're even 6 months older than the other kids, you probably will have an advantage athletically because you're older. So that's a little bit of a fluke of the laws relating to
right, and you could actually
entry.
fix that by just shifting the rules and regulations a little bit.
Well, I don't know. There's always going to be a shift. I mean, there's always going to be a year's worth of variety, right?
Yeah,
in a
right.
year. So you could shift it one way or the other, but you'd still always have that variety, I think.
Well, I was born after the cutoff myself. So I was a year older than most of my fellow graduates. So I was 18 when most people were 17. I was a terrible athlete, not that bright, I suppose, and I was shorter than most people, so I guess didn't work out for me.
Tales of the distribution. But you might have been ahead of everybody intellectually. You might have had more experience, and you might have been getting better grades.
That's not true, but okay.
Well, I'm trying to have...
That might have been. I suppose I could look back.
Tossing you a bone here.
Well, it's combined, of course, with this movement to push curriculum younger and younger in school years, and so you may realize that what you did in first grade is what kids are now doing in kindergarten. They keep pushing it younger and younger, and so that is really what has exacerbated these kinds of issues, is that if we waited until we taught kids to read in first grade, then everybody would cognitively be there by then. But we don't. We do it in kindergarten, and that anyway. So it's politics and also just the date thing.
I think that research, if they could come to some conclusions, would be great, because I know parents can withhold their kids for a year if they think they want them to mature more. At least where I'm from, I think you can maybe even bypass kindergarten.
I think there's
if you want to, or you can wait until they're 6. Yeah.
Well, this is one of the problems with using science. Science basically works in aggregate. And so in aggregate, this is true that kids who are older for their grade are going to have more physical strength and so on and so forth. For any one kid to make a decision like that based on aggregate, to make a decision for one child, it's a little problematic. It doesn't always work that way, right? Because you're looking at big trends. You're not really looking at predicting outcomes for one kid. So that, I think, goes into the bin of a scientific body on minute differences, within 1 year. When you're very young, age differences within 1 year matter a lot. When you get older, they don't matter so much, right? Not that big a difference between a 34 and a 35-year-old, but there's a huge difference between a 4 and a 5-year-old, right? And so it just goes into the body of information about how minute differences when you're young matter, but I'm not sure it's in the category of things we should be making decisions about to try to get our kid into, to get him a college scholarship for football. You know, it's just, there's too much variation here, too many other things.
The idea that such scientific findings should influence policy for when should children be allowed to, you know, what is the cutoff? And there's all kinds of aspects where science informs policy, whether it be the Food and Drug Administration or the testing of our drinking water. And this is where pseudoscience really can have a negative impact, right? So, for instance, one aspect of pseudoscience would be science denialism. And two huge arenas for that would be evolution denial, and that really hampers our ability to train the next generation of biologists and make sure that we have an educated society that understands the implications of evolution and what it means about our place in the world and what it should do in terms of policy setting. And then climate change denialism. So here you have an industry putting out claims that they are scientists that are the minority view, but an important minority view that shows that everybody else is wrong. And they are perpetrating pseudoscience here. They are cherry picking, they are being dishonest, I think, in some instances. And so this is probably the most pernicious pseudoscience that has real policy impacts, that really impacts our way of life and our ability to lead productive lives.
Yeah, you're getting into an area where I could ask a lot of questions about what should we teach in high school and how do we avoid that. But I don't, we could be here for a week or two.
It's true. So it seems like we are teaching a lot of things that might have been taught in high school, but we're making sure that at least by the time students get out of college, hopefully some of these corrective things have been put into place. As we pointed out, the national polls include college-educated people that still believe in a lot of these pseudosciences. As we found some studies that showed that people are almost sometimes more likely, if they have a college education, to believe in some aspects of some pseudosciences. What were some of the ones that came up? Do you remember?
I think ESP was on the list. I can't remember what else.
They were more in the paranormal than in the Bigfoot UFO, right?
More or less,
yes. Yeah, I think so.
More of telekinesis, life after death, maybe even in near-death experiences. But so what happened there, right? So we're trying to advocate for critical thinking that directly targets pseudoscience, because at one level, if you believe in pseudoscience, how much I would say it this way, what proportion you believe in pseudoscience is somewhat related to your level of critical thinking skills and the domains that you know where to apply them. And so we're just trying to put those pieces together.
Oh, well, I interviewed Ray Hyman, Dr. Ray Hyman last year, and he, at the end of the interview, said he wasn't a big fan of critical thinking because, and I'm not saying anything terrible here, I'm just saying he wasn't a big fan of it because he liked to look at the data, and the data should lead you. But I didn't think of this at the time, but now I'm thinking that you could have all the great data in the world and just ignore it or come to a different conclusion based on some bias you have. So
again, he's using critical thinking. See, this is the problem.
Oh, okay, here we go.
It's just not a well-defined concept. So he might be conceptualizing, because critical thinking is clearly involves observation and data and that kind of aspect of the scientific methods, where you don't just have a great idea that's logically consistent. You go out and see if that logically consistent idea maps onto the world in some kind of reasonable way. And so that's the data, right? Let the data guide you. But there's also, Karl Popper said, you can't just say observe with no bias whatsoever. You need some kind of framework to connect your observations. And maybe that you might have an initial inkling, which we might call a hypothesis, that the world's connected in a certain way. You go and check the data, you go and you make some observations, and that informs you. And if you're doing science right, the possibility your hypothesis could be wrong is there. It's falsifiable, in other words. And then you'll make a correction. You'll say, well, that hypothesis is wrong. What part of it was wrong? Can I keep this part and add another part to it and make a new hypothesis? And this is kind of how science progresses. We go out and test it against the real world. If it fails drastically, we make amends, we try to fix it. We don't do it in an ad hoc way. If you do it ad hoc, that means you're protecting it from ever being tested against. But if you add on something that then makes it even easier to test, or makes that's equally falsifiable, and you go out and test that, and that one survives, then you try to find some other thing you can add on until you break it again, and you kind of just build up your scientific theories this way.
And it's a slow process.
It's typically a slow process.
I need to know right now.
Sometimes
Johnny just broke a glass. What do I do?
That's right. And so, but there you'd be then informed by our current best information. And so that would become more of critical thinking aspect, which is sometimes given a separate domain called information literacy. What are your reliable sources of information? Because we all can't be scientists. We can't all make the discoveries. At some level, we have to trust the opinion of somebody else. But whose opinion can you trust? You can trust your parents sometimes, but as you learn more and more, you realize what domains is their knowledge really trustworthy, and what domains do I need to actually go to a doctor? And why do I trust his domain over my parents' ideas? Or why do I go to a scientist or a scientific body? Or why do I read the latest peer-reviewed or a Cochrane report if I want to know something? What is the consensus of medical practitioners on the use of this particular drug? Then that is probably the highest authority and most trustworthy authority you can go to. Trying to convince students why that's the case and that it is the case and this is the best practice, that's kind of what we see as our role in terms of teaching them critical thinking. So it's really multifaceted. It's a simple definition, as you're seeing, is elusive.
Well, I think we need a simple definition.
Oh yeah.
I don't know how simple it can be, but I do
get on
think,
it, you two. And
I do. Well, we're on
I know,
it.
I know.
We're on the job, and a lot of other folks are too. It's really an active area in higher ed, especially. To be accredited in the Western Association of Colleges, Schools and Colleges, you have to be teaching critical thinking, and you have to be assessing how well you're teaching critical thinking. This is a new rule, and so people are trying to figure out how are we going to actually define this, and I think we could have a better conversation about it if Ray Hyman and I were using the same definition of the thing. Then we can have an actual discussion. But it's a really nice example of how him and us and the physics teacher you mentioned earlier put us in the same room, and we'll have a conversation about critical thinking, and none of us are talking about the same thing.
But you think
right?
you are. You haven't defined your term
You're
yet.
using the same word.
Well, I think we would quickly realize,
term.
I think, because we are all, I think, in the discipline where we understand what critical thinking is, but maybe we just haven't gotten together in the room and really said, well, how are we going to explain this to the public? We need a cautious, unified consensus here.
I don't even think that's true. I don't think academia has decided on what the
I'm saying we need
of.
it. That's what we should do. That's what, as academicians.
Well before we could ever present it to the public.
Precisely.
But I don't think even the academicians have an agreed upon definition. I think there's a lot of the people that we teach with think of critical thinking as a deep level of understanding, connecting concepts to one another, and so on and so forth, and that's sort of they're looking at analysis and integration as critical thinking. I tend to adopt this decision-making view, but I think these are two views of critical thinking that are independent, and they sometimes overlap, but not necessarily. And I think this is where we cross wires a lot in our conversations, is that we're not actually talking about the same thing.
And I didn't mean to, above all, I did not mean to disparage Dr. Ray Hyman or this physics teacher. I'm just getting the conversation.
No, we're not disparaging you either.
I understand you want. I didn't want to admit that I had done that.
Yeah, but I'm sure that Dr. Hyman and we would agree on almost all aspects here if we had this conversation. We'd just clarify, well, what do you mean by the data to lead? And we would talk about, well, where's the use of logic and deciding how the data fits into your hypotheses.
But we have encountered this issue too when we try to assess critical thinking. In my own department, we're trying to assess critical thinking, and I sat down with my faculty and said we were trying to assess critical thinking, and we discovered the very same thing sitting around the table, that we had different notions of what that would mean.
Within the same university.
Within the same department within the same department. And there's evidence, Paul, what's his name, interviewed faculty members, about at universities about what is critical thinking, and the major finding was that almost all faculty think it's very important in their classes, and almost all faculty cannot define what it is. They all think it's very important, but they can't actually say what it is, So it exists in this this illusionary sort of space, where I'll know it when I see it. Like maybe, I don't know what.
Well, I think there's been some actually. So, like I was telling Bob Carroll of the Skeptics Dictionary, a philosopher, he puts it down into certain skill sets, and he's got like, I covered it today in my workshop a little bit. So there's a skill set of recognizing our insights, he calls them, about when can we trust our perceptions and our cognitive processes, and when do they sometimes lead us astray? Like the idea of seeing vague stimuli sometimes elicits a face in a cloud or a cliff, and that could, if people thought they saw a ghost, it could have been they mistook a vague stimulus for something that was more real than they should have placed on it. Or this idea of subjective validation, that we read more into something that's said to be about us, and we count the hits and ignore the misses. There's these definite cognitive biases. So that's one thing, is to let students know that there's, or just the general public know, that there are these ways that we can fool ourselves, and we need to be careful about them. That's the first thing. And the second thing, well, there's some logical reasoning that needs to be out there. Like, for instance, if somebody says, why do you do it? Well, everybody does it. That's a fallacy. That's not a good reason, right? That's appeal to the masses. Or why do you continue to use homeopathy? Because it's been around for 200 years. That's not legitimate. That's not good enough reason on its own to continue the practice. That's a fallacy of appeal to tradition. So there's these known logical errors that occur that are part of it. And then there's the whole final aspect, which is, how do I evaluate evidence? How do I know this particular piece of evidence is worthy of informing my belief or not? For instance, if 3 people said they saw a UFO, and they're giving me this testimony, they saw a UFO, is that good enough for me to believe that aliens are visiting us? How about a blurry picture? Is that good enough evidence? What about a piece of metal that's been tested in a lab and it doesn't seem to have the same the nuclear structure and isotopes don't match up to anything that we see on this? Well, that's starting to get closer, right? Like Carl Sagan says, just one little widget from a chunk of a alien spacecraft, we could analyze it, and we look at the isotopic ratios in the nucleus and tell what mine it came from the Earth, if it came from the Earth. We can actually do these kind of things. And so if you have some kind of alien alloy, that would be like a pretty strong indication that you're, but usually
the alloy's there, don't you know?
But it's conspiracy theory then, right? So then we have to talk about, well, how come conspiracy theories don't work? And you kind of go down a rabbit hole pretty quick when you talk about evidence, but I think most students can get this idea that, well, I can't necessarily trust 3 people that don't look at the sky very often what they see. Notice who never reports UFOs is astronomers. Because when they look up at the sky, they know what they're seeing. They know that's Venus twinkling on the horizon, or that's an airplane, because they often see those, or it's a satellite going across. So they have kind of a better guide. Typically, the person that thinks they saw a UFO isn't that well versed with what they're looking at in the sky, and so they can make these perceptual mistakes. So evaluating evidence is where the scientific methodology plays the biggest role. You know, the kind of, what are the safeguards we put in place to make sure that when we see the data, take the data, how do we manipulate the data, that we're not putting in biases, we're not fooling ourselves. I think that's where science has the most to offer. But you see, critical thinking involves all these techniques, having these insights. It involves understanding these logical fallacies and the way you do the reasoning. And then there's reasoning and in evaluating the evidence, which is a whole other domain that is informed from what we've learned about the scientific enterprise for the last 300 years. So it's complicated. I'm not sure it can be boiled down to just a slogan, unfortunately.
Oh, slogan.
Yeah. Although we need a slogan.
Well, I know we're on a schedule here, and I thank you very much for taking the time to speak with me. I should say we are at the Committee for Skeptical Inquiry Conference 2017. I know people like
having
to say
fun
that.
So far.
So I thank you for being here with me. And also thank you for coming out of the university, because this facility, this conference is open to everybody. I don't have to go to Fresno State to see you two. And I know we're on a schedule. I didn't know if maybe you could sum up a little bit why are you here? And what I mean by that, not why are you born and what's your meaning in life here, but you do a lot of work for the public, and I'm the public, so I can read your material. It's readily available. You're at a conference like this. You're speaking. How come you came out of the university? I don't know if I'm saying this question correctly, but do you understand what I'm saying?
Yeah.
Because you could just sit and do your research and teach your college students.
We're here with a like-minded citizens that are concerned about some of the things we just talked about, science denialism. And I think the people at this conference feel that a clear-eyed worldview that takes the findings of science and the methodologies underlying critical thinking seriously is going to be one that benefits the world the most. We hate to see people being abused. I think that it overlaps with human rights and trying to make the best possible planet we can for all of humanity, is somewhat interrelated to how much we trust science and how much we can use our critical thinking. And this conference, I think, represents the readership of Skeptical Inquirer magazine, who are out there trying to prevent the charlatans from taking advantage of people. And I think there's a big overlap with what academia can do in this kind of regard. I think,
Dr. Dyer?
Yeah.
Yeah. I guess I would say that there's a lot of, what is the word I'm looking for? When you stay in your office teaching your classes, doing your research, and I do a lot of it, it's really exciting and fun, and you get very focused on certain things. And but we're learners, you know, and it's really exciting to see in the world other things that overlap in some way, and it's very it produces a creativity, you know, that we don't get if we just stayed at the university. Frankly, it'd be no fun, you know. It'd be no fun.
We're having a good time.
I totally agree with the cross-pollinization. We meet people from other fields that have similar concerns. Oh, like for instance, in psychology, what is the pseudoscience going on there? That's fascinating, and actually, psychology informs some of those intuitions we want our students to develop in terms of what they can trust and what they can't trust about their own cognitive and perception.
There's a depth to what you get to do if you think about how it relates to other things, and so that's what makes it, I think, so exciting to have one area in common and then disparate in all the others, and then you get to really develop some depth, I think, in the way you think about things. And I've enjoyed the conversation. We are always thinking about what is a good definition of critical thinking, and if we only talk to people in our own departments or who teach similar classes to ourselves, we end up with a very narrow view on that. And if we are really seriously thinking about how to define this concept, we really have to be talking to lots of people who are interested in it, and you get that here at SciCon, and it's a broadening on that specific question that I think will make the answer better when we arrive at it.
I look forward to it. Hopefully it'll be within my lifetime. I know science works slowly, but geez. Thank you for coming to my makeshift studio here at the hotel. 502 Conversations, I'm Brian Kirby. My guests have been Dr. Kathleen Dyer and Dr. Raymond Hall. Thank you very much. I appreciate it.
Thank you.
You're welcome.